Burning magnesium ribbon in air. Here are the materials needed for the given activity. Magnesium ribbon, tongs, Bunsen burner or spirit lamp, watch glass or crucible, sandpaper, and moist litmus paper. Now that we know the materials needed, here are some safety precautions before we proceed to the activity. Adult supervision is essential. This experiment should only be conducted under the direct supervision of a responsible adult familiar with chemical safety procedures. Work in a well-ventilated area. Open windows indoors to ensure proper ventilation and avoid inhaling smokes and fumes. And wear personal protective equipment or known as PPE. Use safety glasses, heat-resistant gloves, and protective clothing to shield your skin and eyes from heat and sparks. Here are the procedures. First, clean the magnesium ribbon. Use sandpaper to remove any oxide layer from the surface of the ribbon. Next, set up the Bunsen burner. Light the burner and adjust the flame to a medium size. Next, hold the magnesium ribbon. Use tongs to securely hold the ribbon above the watch glass or crucible. Then, ignite the magnesium ribbon. Carefully touch the end of the ribbon to the flame of the Bunsen burner. It should ignite immediately. And observe the reaction. Watch as the magnesium burns with a bright white flame. Notice the formation of white ash or magnesium oxide falling into the watch glass. Then, finally, that's the product. It is optional. Once the burning stops, allow the ash to cool. Dip a piece of moist litmus paper into the ash. Observe the color change, if any. Here are some guide questions together with its answer regarding about burning magnesium ribbon experiment. First, observation. Describe the appearance of the magnesium ribbon before and after the burning process. Did its color change? Explain why or why not. Initially, the magnesium ribbon appears as a shiny silver strip, but after the burning process, it undergoes a transformation into a white powdery substance. This change in appearance from metallic silver to white results from the reaction of magnesium with oxygen in the air, resulting in the formation of magnesium oxide. Second question, reaction type. Is this experiment demonstrating a physical or chemical change? Justify your answer based on the observed evidence. These experiments illustrate a chemical change. The observed evidence of the color change and the formation of a new substance support the conclusion that a chemical change has occurred. Third question, energy. Does the burning magnesium reaction release or absorb energy? How can you tell from the experiment? The burning magnesium ribbon releases energy, for as it can be seen in the experiment that it releases light and heat. Fourth question, product properties. What is the white ash produced during the burning cold? Describe its physical and chemical properties based on the experiment and any additional knowledge you have. The white ash that was produced in the experiment is magnesium oxide. It is usually found in white powder form and produced by heating magnesium. Its chemical formula is magnesium oxide, MgO. The fifth question, chemical equation. Write a balanced chemical equation to represent the reaction between magnesium and oxygen that occurs during the burning process. Explain the meaning of each symbol and coefficient in the equation. The equation is two monoatomic molecules of magnesium react with one molecule of oxygen to produce two molecules of the compound magnesium oxide. For the explanation, first, we need to identify the type of bond and reaction. This is an ionic bond, so atoms are given and accepted electrons. This is a synthesis reaction. Magnesium has a charge of 2 positive, while oxygen has a charge of 2. The burning of magnesium metal reacts with oxygen found in the air or oxygen gas to form magnesium oxide. Oxygen is a diatomic molecule and it's almost always reacting with the elements as a gas. For the bonus question, alternative fuels. Based on the properties of magnesium and its reaction with oxygen, can you think of any potential applications of magnesium as a fuel source? Discuss the advantages and limitations of using magnesium compared to traditional fuels. Magnesium can be utilized as a fuel source for electric vehicles, outdoor activities, and metal producer. Compared to the traditional fuels, magnesium has a higher accessibility as it is abundant and recyclable. The emissions of the magnesium also separates it from the traditional fuels because it releases primarily harmless magnesium oxide. This is just the two of many factors on why magnesium separates from traditional ones as a fuel source.